The 4-bit AI on your laptop was made the quick and naive way, but its maker also ships a more carefully built 4-bit version for free, and almost nobody bothers to run it. So I put both versions of that same model through the identical graded exam on one machine to settle whether that better built 4-bit is actually worth switching to, then price the difference. This test only exists because a viewer pushed back on my last result, so let's settle it in public. By the way, if you want to run these benchmarks yourself, I've linked the raw JSON data and the React code I'm using down in the description for free. Here's the setup, and the one rule that keeps it honest. The model is the same, and the 4-bit class is the same. Same weights, the same 15-task exam from the quality episodes. Deterministic graders, temperature pinned to 0. No second AI judging the first on one machine. The only thing I change is how these 4-bits were made, because there are 2 ways to shrink a model to 4-bit, and the industry quietly treats them as the same thing. They are not, so whatever gap shows up, the method made it, nothing else moved. And the difference fits in a sentence. The normal way, post-training quantization, takes the finished full precision model and just rounds every weight down to 4 bits afterwards, like compressing a photo that's already shot. The smarter way, quantization aware training, trains the model while it's already pretending to be 4-bit, so it learns to place its weights where the rounding won't hurt. Same 4-bits coming out, and in theory, more of the model's brain survives the squeeze. That's the claim we're putting to the test. The first is what your laptop runs today. The second is what we're testing. Now, one honest catch, and it's the same wall as always. The training aware build I needed is bigger to load than a cheap laptop can hold. It wants about 16 gigabytes of memory, and a budget machine doesn't have it. So instead of pretending, I rented a machine that does, for a few cents of cloud credit, and ran both 4-bit builds on that same box. So the hardware is identical, the only variable left is the method. The wall didn't disappear, I just borrowed a bigger room for an afternoon. So I gave them both the exam, same 15 tasks, same grader, back to back. The naive 4-bit build, the one your laptop already runs, scored 80%. The training aware 4-bit build also scored 80%. The gap is 0. Sit with that for a second. The carefully built one is a flat tie on accuracy, but it generates those answers about 9% faster for under a gigabyte more on disk. The speed is real. The accuracy upgrade everyone assumes simply isn't there. So here's the number that matters, the one I put us on a sticky note. And to be honest, it's not an accuracy number because there isn't one. Training aware 4-bit tied the naive build exactly, 0 points separating them on this exam. Honestly, it was smaller than the hype suggested. The accuracy is a flat tie, but here's what did move, the speed. 32 tokens a second for the training aware build versus 29 for the naive one, about 9% quicker, at the same score for free. And I want to kill the obvious objection before it starts. Sure, but the training aware build must be bigger. It is slightly, 8.1 gigabytes for the naive build, 8.9 for the training aware one. Both fit on any machine with 16 gigabytes. And the difference is less than a single episode of a TV show. Speed on the same box, 29 tokens a second versus 32, a 9% edge for QAT. You're not grading accuracy. You're not trading memory in any meaningful sense. You're getting a small speed bonus because someone trained the model right and then gave it away. Because I promised you honest, so here's the ceiling for all of this. You only get a training aware build when the people who made the model bother to ship one, and most of them don't. Google does it for Gemma, which is exactly the model of viewer who suggested this runs. For most other models, the training aware 4-bit simply doesn't exist, and your only option is the naive kind. So this isn't stop using normal quantization. It's when a maker hands you the training aware build for free, take it, same accuracy, 9% faster, and when they don't, naive 4-bit is still the one that fits, and is still good. Let me put it in the only unit that pays the bills, and this part is modeled on measured at the same accuracy and a 9% speed advantage. The training aware build costs about 8% less per correct answer, not because it's smarter, but because it's quicker, and the machine runs less time to get to the same job done. On a cheap rig where the 4-bit model is the only one that fits anyway, a free speed bump that costs 0 extra accuracy is about as close to a free lunch as this channel ever finds. So was the viewer right? Partly, and I owe him credit out loud. Shout out to SK Mine Forever, who pushed back in the comments and sent me down this hole. He was right that QAT exists and right to flag it. The accuracy is a flat tie, 0 points either way, but the real prize is the 9% speed advantage for under a gigabyte more on disk. He runs a 16 gigabyte machine, so I've handed him the exact same public harness. If his numbers match mine, that's 2 rigs, 1 result, and you don't have to trust either of us. Here's the takeaway, measured rather than guessed. Train where 4-bit doesn't buy accurate points. On this exam, it's a flat 0-point gap. What it does buy is a 9% speed advantage for under a gigabyte more on disk, which on a cheap machine is the difference between a model that feels fast enough and one that feels sluggish. So the rule is simple. Ask if a training aware build exists. If it does, take it. If it doesn't, naive 4-bit is still the one that fits and is still good. The data and code are linked below. Next time, Now that we know which 4-bit to run, the bigger question, which jobs are worth keeping local versus paying in the cloud, measured per task. This has been the validation set. Subscribe, and I'll see you there.